Now action with non-metallic oxide. Right now we have seen action with metallic oxide. What we have observed? Action with metallic oxide. Metal oxide reacts with any acid to give salt and water. So that proves our conclusion is metal oxides are basic in nature. Now non-metallic oxide when reacts, what will form? Acid reacts with metal oxides because bases reacts with oxides of non-metals like carbon dioxide, sulfur dioxide and sulfur trioxide, okay, to give salt and water. Now let's see here, sodium hydroxide reacts with carbon dioxide. You are getting sodium carbonate and water. Sodium carbonate is a base here, is a salt here, and water. Now we have already discussed that under the acids that carbon dioxide turns lime water containing traces of calcium hydroxide milky due to the formation of insoluble calcium carbonate. Lime water turns milky. Why? Because that milky color PPT is calcium carbonate which is insoluble in that particular solution. That is why it will separate as precipitate and you are seeing a milky color solution. Now carbon dioxide when reacts with calcium hydroxide, you are getting calcium carbonate white PPT. Same way potassium hydroxide reacts with carbon dioxide, you are getting potassium carbonate and water. Okay. What do all acids and all bases have in common? What is the common thing about them? Whenever they react with any acid, they liberate hydrogen gas. Okay, this is one thing common. Now we can say all acids and bases are having their own characteristic reactions. Both produce hydrogen gas when they react with certain metals. Okay, now to know this, we have some experiments to perform. Few materials are required: dilute hydrochloric acid, dilute sulfuric acid. Dilute solution means we have taken two acids here. Dilute solution of sodium hydroxide, we have taken a base also, ethanol and glucose solution. Now see, strong acid, strong base, or weak acid, weak base, or salt solutions will undergo, which is bonded with the ionic bond. There are chemical bonding you will study. Under that there are two types of bond, ionic bond and the covalent bond. Ionic bond are the bond, very strong force of attraction is called electrostatic force of attraction. That substances when dissolved in water under the influence of some kind of energy, they are breaking into ions, dissociate into ions. Okay, so they are providing passage for current, so they can be a good conductor of electricity also because ions are providing passage for current. Now but some of the substances which bonded with covalent molecules, so they are not undergoing any ionization, like glucose molecule. If you pass glucose solution electric current also, it will not ionize to any ions, carbon, nitrogen, oxygen ions you will not get it. Why? Because it is in a form of molecule, so they cannot undergo ionization. Okay, so glucose is there, then ethanol is there. They are covalent compounds. They are soluble in water because they are actually covalent compounds are insoluble in water, but few covalent compounds are soluble in water because they form hydrogen bond with water. So whichever can form hydrogen bond, like honey, ethanol, glucose, can form hydrogen bond with water, so they are soluble in water. Otherwise the covalent compounds are not soluble in water, like for example petrol, kerosene are not soluble in water. They are forming separate layer on the top. Okay, so we have taken this material, we have taken some ionic compounds, some non-ionic compounds. Then apparatus required, we have taken one beaker, 2 electrodes, dry cells, bulb, 1.5 volts and key. Now take a beaker, place 2 carbon electrodes into it. In a beaker they have placed the electrodes. Connect the electrodes to battery through a dry cell. Okay, pour dilute HCl into a beaker and press the key. Did the bulb glow? When the circuit is completed, bulb will glow. Perform the similar experiment with all the given solution. So we will just try to predict it. If HCl is added, bulb will glow. Why? Because HCl is a strong acid which ionizes to H plus and Cl minus. So current, electric current can pass through the ions. Passage for electric current is ions. So it is possible. So bulb will glow. If we talk about sulfuric acid, also bulb will glow because there will be H plus and SO4 2 minus ions. Okay. If we talk about NaOH, dilute solution of NaOH, that will also break Na plus and OH minus. So wherever ionization is taking place, there the bulb will glow with the better intensity because number of ions are present which are providing passage for electric current. But whenever we are adding ethanol or glucose solution in a beaker and try to connect it with the electricity and on the key, so there will be bulb will not glow. Why? Because there are no ionization. So when they are not ionizing, they are not conducting electricity. Okay, so they cannot conduct, they are non-conductors. Like we can see here, for example, HCl solution in water in a beaker, what will happen? There will be plenty of ions. HCl will break as H plus and Cl minus. Separation of HCl into H plus and Cl minus will be possible in presence of water, and this process is called ionization, converting into ions. Like H plus and H2O will give H3O plus hydronium ions. So this happens because H plus ions are not stable and ionization will take place here. Now we can see comparison with two experiments. See where strong acids, strong bases are added here in dilute HCl solution. In rubber cork, two electrodes are there, and when the circuit is completed with the help of battery in a beaker, HCl solution is there. What will happen? The bulb will glow. Okay, but if we add here, for example, glucose solution, so there are no ionization, so no ions to provide passage for electric current, so bulb does not glow. Okay, so we can see here what is the conclusion? We conclude that hydrogen containing compounds such as glucose and alcohol are not acid. So every substance which contains hydrogen is acid. That is also wrong. That is not like that. Substance should undergo ionization to break into ions, and ions will provide passage for electric current. Okay, so they do not dissociate in water to give H plus ions. So this glucose solution did not dissociate to give H plus ions or any kind of ions, and because of that, what is happening? The electric current circuit is not completed and bulb is not glowing. Okay, so the aqueous solution of acid conducts electricity due to presence of charged particle of ions in it. Okay, now here is one table which are the solutions we have taken in beaker with electrode and complete the circuit. If dilute hydrochloric acid is there, bulb is glowing. Why? Because hydrochloric acid is breaking as H plus and Cl minus. Okay, so ions are present, so bulb is glowing. Okay, so it is conducting electricity via these ions. If dilute sulfuric acid is taken, it is also breaking as 2H plus SO4 2 minus. So because of presence of ions, the electric current is passing and it is conducting electricity. Bulb is glowing. Dilute NaOH solution, NaOH will break as Na plus and OH minus. Okay, so again bulb is glowing and electricity is conducted. But in case of ethanol, they are in form of molecule, and glucose, they are not undergoing any ionization, so there are no ions, and that is why they are non-conducting and bulb does not glow in this case. Okay, then the solution of acids and bases are good conductors of electricity. The solution of glucose and ethanol are non-conductors of electricity. We are getting it? Why it is happening? Because solution conduct electricity due to presence of ions in them. Therefore, acids and alkalis furnish ions in their solutions. Acid produce H plus ions. Bases produce OH minus ions in their solution in water. But ethanol and water and other solution of glucose do not conduct electricity because they do not produce ion in their solution. Thus the tendency to produce ions in their solution in water is a common property of acids, bases, alkalis. Okay, let's see now properties of bases. What are the special properties of bases? We can see here few bases. Picture is also given how they look. This is sodium hydroxide. Sodium hydroxide looks like a pellets, small pellets. Okay, then calcium hydroxide is present here. Then we have potassium hydroxide. Potassium hydroxide is not shown here. Ammonium hydroxide is in the form of liquid. And we have magnesium hydroxide. It looks like flakes. Okay, so these are the substances, bases, which is soluble in water is also called an alkali. So on dissolving in water, they are undergoing ionization. So what kind of ionization? NaOH will give Na plus and OH minus. CaOH2 will give Ca2 plus and 2OH minus. Correct? Then we have here KOH will give K plus and OH minus. Okay, NH4OH is a weak base, but it will also give NH4 plus and OH minus. Okay, then magnesium hydroxide will give Mg2 plus and 2OH minus, like this. So all are giving OH minus, that will be indicating the substance are alkaline in nature. Now we see here strong bases like KOH, NaOH are strong bases. The bases which gives more number of OH ions in aqueous solution are called strong bases. Means complete ionization will take place. When ionization is complete, what is it called? Word for this, complete ionization. Okay, when ionization is complete, substances are strong acids or strong base. When incomplete ionization, here partial ionization we can say, partial ionization. So what will happen in partial ionization? There will be some ions as well as some of the undissociated molecule is also staying in the solution, and because of that there is ionization is incomplete and less number of hydroxide ions are obtained, and because of that they are weak bases. Okay. Now we have studied about base. Bases have bitter taste, bases feel soapy to touch, and bases turns red litmus blue. Okay, you can remember that way only. Red is turning blue, blue is from B, so B is for basic. So red is turning blue, so it is basic solution. Okay, so we have, these are the properties of bases which we have covered in today's class. So keep watching.